Hello, everyone. My name is Albert Strow, President of Smart Talk Beacon Solutions. I'd like to start by thanking the industry leadership at IEEE for the opportunity to present at today's Global Communication Conference. Our topic is BOMs, a prerequisite for the next generation network. Many of you will be familiar with the Executive Order 14028 that introduced new regulations for companies supplying products and services containing software to the U.S. government. The order sets minimum requirements for BOMs. This illustrates the relevance of SBOMs related to security. The goal of today's presentation is to define the requirements and some of the reasons new communication infrastructure and architecture is required. BOMs are important to this conversation. Hardware, software, and network bombs will be referred to as BOMs in this presentation. The objectives are as follows. We want to outline how BOMs are needed to help security systems, support path management, and how our services work with BOM information. Illustrate why a SRP Net OS is the next generation network. Touch base on how information management must change. And outline how participation in SRP will benefit developers and researchers. At this point, I'd like to pass it on to Stephen Carbno, Chief Architect and Programmer, who will speak on BOMs. Let's welcome Stephen.
Thank you, Alfred. What is a compute infrastructure? A compute infrastructure is composed of hardware, software, and the network connections. The hardware can be broken into items such as motherboards, CPUs, GPUs, and other components. Similarly, we can look at the software that operates on the compute environment. This includes operating systems and processing packages. Lastly, we look at the connection methods or interfaces. Various connection topologies and connection types are available, such as wireless, Ethernet, and other types. Each of these components have a bill of material. A bill of material being a structured list of product components with related information. Here we define three types of bill of materials: a hardware bill of material, a software bill of material, and a network bill of material. The network bill of material is important for network operations. Network bills of materials' primary role is an information repository. We'll explain this more in detail later. So let's say we have a device. What are they? We need to have a way about describing information about devices. A bill of material can be used to describe both the device and its connections. This example is an extremely simplified viewpoint, but it's a starting point to understand about what would be contained. A hardware bill of material is the physical components of the device. In one case, we have a wireless access point. In the other case, we would have a car. The software bill of materials can be described as the functional view, since the application runnings on the devices define the functions. The wireless access point is running OpenWRT, and the car is running an AI navigation software. It is important to capture both the device's hardware and software information. This information is needed for security and support processes. The majority of the software bill of materials use cases are used to evaluate risks. The risk could be a potential software fault of any sort. Data in the hardware bill of materials and software bill of materials define potential vulnerabilities to be resolved. This information can then be used to automate processes to reduce risk from vulnerabilities. However, additional information needs to be collected to answer these questions. How are these devices trying to connect? Should the connections be allowed? And what are the characteristics of any of these connections? The network bill of materials, just like a software bill of materials, is a repository of important information needed to help secure network operations. The network bill of materials in the network interfaces and the associated properties that that system connect with. An example for the wireless access point would be wireless 6, and for the vehicle could be an optical wireless system like Li-Fi. Network bills of material has two important processes. The first important process is the creation of inventory related to services and functions with links to software bills of material. These services or links of applications that are available and connected. This means the device can provide this service to the global system. An example of this would be something like a website or an API endpoint. The other important process is the network interface information, such as the hardware, the quality of service, the medium, and the connection points. This part of the network bill of materials describes the characteristics of each of the links that this device has to the outside world. Network bills of materials are independent of hardware bills of materials and software bills of materials, but they reference elements of each of them. The network bills of material informations of different nodes can be combined together to create a knowledge tree. This knowledge tree gathers supporting decisions and allows us to support decisions related to path management, security operations, network operations, and information management. BOMs is the combination of hardware bills of material, software bills of materials, and network bills of materials. BOM information contains the information required to support network operations and risk management. Some of the BOMs specifically support a core set of architectural services. Some of this includes operational information such as quality of service, health, security monitoring, data custody, access control, application service awareness, and some of the operational services include network path management, network path definition, bandwidth management, distributed data services, time-sensitive networks. All of these services help us do risk evaluation and management. This represents a new architecture for the next generation of networks. I will pass this back to Alfred to introduce the SRP NetOS.
Thank you very much, Stephen. We're doing a little bit of a transition because we're going to speak about this whole new concept of SRP and NetOS. A NetOS is a communication architecture required for securely sharing services, information, and operations between owners. A NetOS is a defined network. It is not a hardware-defined network. We must merge security, network operations with IT operations to create one environment that supports virtualized services and information management everywhere. SRP implementations are exclusive, defined by SRP owners. Owners' exclusivity is maintained until they choose to define a relationship with another owner. All relationships between owners are defined in policy, which will be discussed later. Let's compare the idea of a network, a new type of computer network, to the human nervous system. Nodes equal neurons, relationships, nerve complexes, and shared services are distributed systems in the human body, such as the nervous system and hormonal system. Organ control is a complex process composed of many nodes and functions that all work together. Complex functions require coordination between many parts. SRP NetOS is composed of many distributed nodes working together to become greater than individual parts. NetOS is flexible, performing different tasks defined by the needs of users. Relationship management is core. So BOMs are driven by node relationships. They can be looked at as need, control / policy, and method. Owners have nodes. Owners define relationship needs with agreements with other owners. Agreements are translated into policy. The implementation of policy is controlled using access control and various other security methods defined in no trust security. BOMs is one method used for inter-node operations within the net OS. I'd like to pass it back to Stephen to talk about the reference architecture.
Thank you, Alfred. So in this diagram, we're going to have two illustrating the two major components required to manage an infrastructure. Component one is the Information Exchange Framework, which is an OMG standard found under the main Information Exchange Framework reference architecture. The IEF is a policy engine and information management service for users and data services. The use of metadata is important for information management, and the SRP NetOS is the secure communication and management infrastructure. The SRP includes a new stack that allows businesses to move beyond the basic services offered by TCP, IP, and other protocols. In a sense, the SRP NetOS deals with the problem of data creation and data in motion. The IEF services deal with the problems of data at rest and data at use. Please note the direct relationship of hardware bills of materials to hardware, software bills of materials to applications, and network bills of material to network operations. The Information Exchange Framework defines 7 reusable services tailored to the protection of data assets. These services or service patterns can be implemented and configured to enable information sharing and safeguarding and data-centric security for email, chat, file share, system-to-system messaging, streaming data, and more. The difference is that the IEF focuses on access to data and information assets rather than networks, platforms, systems, and applications. It is this focus that is unique. The Information Exchange Packaging Policy vocabulary defines a lightweight UML profile for developing information sharing and safeguarding and data-centric security for structured and semi-structured data environments. The IEPPV enables the definition of reusable and configurable data and exchange patterns that can be used by model-driven architecture and model-based system engineering tools to automatically generate runtime information sharing and safeguarding and data control security policy, which is enforced by the packaging and policy services. This, over the last 5 years of testing at NATO, CWIS, the IEF demonstrates the ability to provide agile policy deployment and dramatically reduce the time to operations. The SRP NetOS deals with data creation and data in motion problems. The IEF deals with data at rest and data at use. The SRP and IEF elements can both be used, however, within the same policy going forward. The secure architecture components are health, pathing, registration, no trust security, relationship management, distributed data services, time-sensitive networks. Note, new services and functions are automatically protected with security, access control, and data target definition. This simplifies development and deployment. Policy drives input information, which derives operation and core policies, as seen on the left-hand side of the slide. This allows then for information creation to lead to information management and thereby going to information sharing as seen on the right-hand side of the slide. To do pathway management with SRP, you must have knowledge and policy. To get the policy knowledge, we take this from the policies that we have generated in SRP. The main source about where the network information comes from the network BOM. This allows us to have simple policies for complex problems. There are two factories with two, in this example, there are two factories with two types of connections. A fiber connection is available between sites. A wireless connection is available between sites. A wireless is also available within the buildings at each location. The policy is production data must be sent over fiber connections. The questions are, what is production data? Where is this data located? Who has access rights to production data? What are the devices and what pathways? This simple policy can be broken down to a series of tasks and problems that can be solved. The task of figuring out what is production data, who creates it, where is it stored, and who has access is an IEF policy. The path management of asking what connections are fiber, what is the best path, and is this time-sensitive network necessary, is answered through NBOM information in SRP policies and NBOM information in general. And the diverse data target, which says which devices this policy applies to, which servers, and how which do these devices interact and change because of this, is the combination now of IEF plus SRP policies. This allows policy to solve very complex problems. Policies and patterns will be discussed further with Alfred here, followed by an outline of business opportunities.
Thank you again, Stephen. What is the relationship between policies and patterns? Policies are the implementation of patterns. Patterns define specific needs. Policies define the implementation. Policy-driven systems deliver flexibility of implementation and ease of change, two important considerations in the future of systems. Patterns and policy. Patterns determine policy. Policy derive implementation. There are several parameters that policy needs to cover, including pathing, governance, relationships, processes, and almost all of the other requirements of a system. So why are patterns important? Reuse is the primary motivation for patterns, where we can identify commonalities, identify components, which include the rules and processes, and reuse components, especially by creating the granularity that's appropriate for optimal reuse. There are two major categories of patterns: operational patterns, which are security, governance, and process patterns. And finally, data information patterns, components for reuse of rules such as database rules, file rules, and DDS. There are vertical specifications that are more easily defined with the use of patterns and levels of patterns. In this illustration, we show how the SRP NetOS core architecture supports standardization of with the interface module or API. The SRP core is composed of a set of standard patterns. This makes it possible to create vertical patterns, pattern libraries for reuse. Patterns have a granularity appropriate for optimal use. Patterns are important for identifying processes needed to implement in policy. We define the rules to be followed, and then we implement those rules in policy. Being able to visualize relationships of elements in pattern helps with understanding behavior and relationships. Visualization tools help with the policy definition and can also display conflict issues. Visualization processes make patterns and policy definition easy. This leads to change management processes for implementation. Digital twinning in this environment can leverage patterns to help run a simulation to determine if the results meet your needs prior to implementation. These ideas have a vision, and the visions are for networks that need to be responsive, intuitive, omnipresent, so that people can safely use information services to improve life. Businesses need the freedom to safely create relationships, perform transactions, and share information with others. People need an infrastructure to support freedom to choose who to share information and interact with without the fear of loss of privacy and information. The next section is a change of pace again, where we're focusing on the SRP community. The SRP community is the community developed or implemented so that we can deliver this technology for the benefit of everyone. So it empowers users and partners through sharing information services and business development opportunities. SRP is a limited company established to hold the licenses, the technology license such as SRP, IEF, and other solutions used within the core. These technology assets, along with funding partners, become the founding partners for the SRP and SRP management board. Our SRP open source release will be non-extendable, but partners gain by extending the core with custom enhancements and custom development. Community empowerment is important. SRP core interface module supports customization of vertical market development and new service delivery by both partners and users. Case studies and test beds with industry associations provide input, test, and validation of our SRP implementations prior to release. The SRP core standards will be maintained by a product development team. Once defined, the standards change will be carefully considered and managed. SRP will provide maintenance and support services to licensed clients. Suggestions will be collected and to define system enhancements. The CCE is a third-party research and validation organization owned by the University of Regina. The Communication Center of Excellence, its primary goal is for relationship. For this relationship is to establish a network of specialized expertise for defining best solutions and practices for a wide range of technologies required to complete the core. Funding partners, including businesses, industry, and government, are important for delivery of resources needed to complete the project. Funding will be direct to SRP, development partners, or CCE based on need. Each contributes to the community development of the NetOS. The goal is to create a new secure communication infrastructure for sharing information and services. SRP NetOS will serve the needs for security, privacy, control, and accountability for everyone, big and small. I would like to thank you for your attendance, and if you would like any information, please feel free to contact us at any time. Thank you very much.